Good morning, dear students.
Good morning.
How are you all?
Fine.
Fine. Okay, so today we are going to have a small session of experiential learning, and today I will try to show you through demonstration that what is the importance of concentration, what is the importance of path length. To cut short, today we are going to talk about the Lambert's law. So now in front of you, you can see that this is a concentrated solution of potassium permanganate. It is of an unknown concentration, so I will not go into the details of the concentration. I would just like to demonstrate two small things, that what is the effect of concentration on the absorption spectrum as well as what is the effect of path length on the absorption spectrum. So now here you can see that I am having two different type of glassware. One is of course a measuring cylinder which has got a smaller diameter, and I have a small beaker of 100 ml. This has got a different diameter. Now what will happen if I pour this uniformly concentrated solution into these different crucibles? Let us see. Now, what is the difference that we are observing in these two different type of glassware? We can see that one is looking a bit denser and the other one is looking a bit lighter in color. What is the reason behind the difference in this color? The reason behind this is that the light which is falling on this particular glassware is traveling only a small distance before coming out of the system. So it is traveling only this bit of the diameter. Whereas in this glassware, the light is actually traveling a longer distance, and because of that reason, light is being absorbed more in this particular glassware and light is being absorbed less in this glassware. That is why this is looking denser and this one is looking lighter. Let us take another example. If I take another crucible which is even more wider in diameter, now what's happening? The earlier one, which was a bit more denser, is now comparatively lesser denser than the other crucible which is having the bigger diameter. So this proves now all the solution in all of these three glasswares are actually the same. But this is absorbing the maximum light, this is comparatively absorbing lesser light, and this is absorbing the least light. This shows that the crucible, or if the incident light is traveling more in the solution, it will be absorbed more.
Yes.
Whereas if it travels less in the absorbing system, then it will be absorbed less.
Yes.
So this is nothing but the demonstration of this law, wherein it clearly tells that absorption will be higher if the path length is more. Now this diameter can be equated as the path length of the system, and therefore we can see that if the path length is higher, then of course the absorption will be higher. Now let us take another example of this particular. Now what I am doing is, please have a look. Now this is the same concentration of the liquid, okay? And I have another glassware which is having almost the same diameter as this previous conical flask. Now let us see. Now this is actually liquid from the same crucible. Of course they are having the similar concentrations. What will happen if I dilute one of the systems? Let us see. So what I have done now is that in one of the crucibles, the liquid is concentrated, the solution is concentrated, whereas in the second one, the concentration is now a bit lesser. What is the difference? The difference is that the crucible in which the concentration is higher is looking more concentrated, it is absorbing more light, whereas the one which is having lesser concentration is absorbing less. So this also demonstrates that depending on the concentration, absorption will be directly proportional. If the concentration is higher, then absorption of light in that particular system will be higher. If the concentration is low, then absorption will be low. So these two laws are actually the laws that govern the absorption in UV or visible spectrophotometry.